Our story begins billions of years ago, in the vast expanse of the cosmos. Imagine a vast, dark cloud of gas and dust drifting through space, seemingly lifeless and still. This cloud, called a nebula, was the birthplace of our solar system, a cosmic nursery where stars are born. Gravity, the architect of the cosmos, slowly pulled the cloud's particles together, initiating a grand cosmic dance. As the cloud contracted, it began to spin faster and faster, like a spinning figure skater pulling in their arms, conserving angular momentum. At the cloud's center, the material became incredibly dense and hot, forming a glowing core. Eventually, the temperature and pressure became so intense that nuclear fusion ignited, a process that powers the stars. Hydrogen atoms fused together, releasing an incredible amount of energy in the form of light and heat. Our sun, a brilliant star, was born, illuminating the darkness of space. The sun's birth marked a turning point in the story of our solar system, a beacon of light and energy. Its powerful gravity would shape the destiny of everything that followed, pulling planets and other celestial bodies into orbit. From the remaining gas and dust, a swirling disk formed around the newborn star, the protoplanetary disk, the cradle of planets and moons. This disk held the building blocks for everything we know and love in our solar system, the raw materials for planets, moons, and other celestial bodies. Around the young sun, the protoplanetary disk teemed with activity, a chaotic dance of particles and gases. Dust grains, remnants of the original nebula, collided and stuck together, driven by the forces of gravity and electrostatic attraction. Over millions of years, these tiny particles coalesced into larger and larger objects, forming planetesimals, the building blocks of planets. This process, called accretion, is like building a snowman, starting with small snowflakes that gradually clump together to form something much bigger, layer by layer. In the inner region of the disk, where the sun's heat was most intense, rocky materials like iron and silicates could withstand the high temperatures, remaining solid. These materials became the building blocks of the inner planets: Mercury, Venus, Earth, and Mars, each with its unique characteristics and composition. Further out, beyond the frost line, temperatures were cold enough for volatile compounds like water ice to exist, creating a different environment for planet formation. Here, in the realm of giants, gas and ice accreted to form the gas giants: Jupiter, Saturn, and eventually Uranus and Neptune. With their massive size and powerful gravitational pull, these behemoths would play a pivotal role in shaping the destiny of the entire solar system, influencing the orbits and formation of other celestial bodies. Among the planets, Jupiter stands out as a giant, its mass greater than all the other planets combined. Its formation was a defining event in the solar system's history. As Jupiter grew, its immense gravity acted like a cosmic sculptor, shaping the surrounding space. One leading theory suggests that Jupiter, in its early days, embarked on a grand migration, moving inward toward the Sun before reversing course. This grand attack hypothesis proposes that Jupiter's gravitational pull scattered planetesimals like a cosmic billiards game, preventing the formation of a large planet between Mars and Jupiter and contributing to the asteroid belt's formation. Jupiter's influence didn't stop there. Its gravity also helped to clear the early solar system of debris, preventing catastrophic collisions that could have disrupted the formation of the inner planets, including Earth. In a sense, Jupiter acted as a planetary guardian, shielding the inner solar system from chaos. Between the orbits of Mars and Jupiter lies a vast region populated by remnants of the solar system's formation, the asteroid belt. This cosmic debris field contains millions of asteroids, ranging in size from small pebbles to dwarf planets like Ceres. These rocky bodies are time capsules, offering clues to the early solar system's conditions. The asteroid belt's formation is linked to Jupiter's gravitational influence. The giant planet's gravity prevented these planetesimals from accreting into a larger planet. Instead, they remained trapped in their orbits, colliding and fragmenting over billions of years. Studying asteroids provides valuable insights into the composition of the early solar system and the processes that led to planet formation. The asteroid belt serves as a reminder of the dynamic and often chaotic processes that shaped our cosmic neighborhood. Section 5. A titanic collision, the birth of the Moon. Earth's early history was a time of intense upheaval, marked by violent volcanic eruptions and a tumultuous landscape. Around 4.5 billion years ago, a cataclysmic event occurred that would forever shape our planet and its destiny: the formation of the Moon. This event was a turning point in the early solar system. Scientists believe that a Mars-sized object named Theia collided with the young Earth in a colossal impact, one of the most significant events in our planet's history. The energy released in this impact was unimaginable, melting and vaporizing a significant portion of both bodies. The collision was so intense that it reshaped the very structure of our planet. Debris from the collision was ejected into space, forming a ring of molten rock and dust around the battered Earth. This ring of debris would eventually give rise to our Moon. Over time, this debris coalesced under its own gravity, eventually forming the Moon we know today. The process took millions of years, but the result was a satellite that has been our constant companion. This giant impact hypothesis is supported by several lines of evidence, including the Moon's composition, which is remarkably similar to Earth's mantle, and the Moon's orbital characteristics. These clues help scientists piece together the story of our Moon's dramatic birth. The Moon's formation had profound consequences for Earth, influencing its geological and biological evolution. It stabilized Earth's axis of rotation, creating the regular seasons that would be crucial for the development of life. Without the Moon, Earth's environment might have been too chaotic for life to thrive. Section 6. Unlocking Lunar Secrets: Missions to the Moon. The Moon, Earth's closest celestial neighbor, has captivated humanity for millennia. But it wasn't until the dawn of the space age that we could finally unlock its secrets. The Apollo missions, a testament to human ingenuity and exploration, landed the first humans on the Moon in 1969. Astronauts collected lunar samples, conducted experiments, and planted the American flag on the lunar surface, marking a pivotal moment in human history. Analysis of lunar rocks brought back by the Apollo missions revolutionized our understanding of the Moon's formation and history. These missions confirmed the giant impact hypothesis and revealed the Moon's ancient volcanic activity. Moreover, lunar exploration has spurred technological advancements with applications here on Earth, from communication satellites to medical imaging techniques. Section 7. From Chaos to Cradle: Early Earth. The early Earth was a far cry from the habitable planet we know today. After the Moon-forming impact, Earth was a hot, molten world constantly bombarded by asteroids and comets. Volcanoes erupted across the planet, spewing gases into the atmosphere, which was very different from the air we breathe today. Over millions of years, Earth began to cool down. Water vapor in the atmosphere condensed, forming oceans that covered most of the planet's surface. These early oceans were teeming with chemical compounds, setting the stage for the emergence of life. While life's exact origins remain a mystery, scientists believe that it likely arose in these early oceans, perhaps near hydrothermal vents, where heat and chemicals from Earth's interior provided energy for primitive life forms. Section 8. A Tale of Three Planets: Earth, Mars, and Venus. Earth's story is best appreciated when contrasted with its planetary siblings Mars and Venus. These three rocky planets share some similarities but have experienced vastly different fates. Mars, once a warmer, wetter world, lost most of its atmosphere due to its weak magnetic field and lower gravity. Without a protective magnetic shield, the solar wind stripped away Mars's atmosphere, causing its oceans to evaporate and leaving behind a cold, arid desert. Venus, on the other hand, experienced a runaway greenhouse effect. Its thick atmosphere, composed primarily of carbon dioxide, trapped heat from the sun, leading to a surface temperature hot enough to melt lead. Earth, with its moderate temperatures, liquid water, and a protective atmosphere, stands out as an oasis of life in the solar system. Section 9. Earth's Balancing Act: A Habitable Planet. Earth's ability to support life is a testament to its remarkable systems of self-regulation. Its magnetic field, generated by the planet's molten core, acts as a shield, deflecting harmful solar radiation and protecting our atmosphere from being stripped away by the solar wind. Plate tectonics, the engine of Earth's continents, plays a crucial role in regulating the climate. The carbon cycle, a complex interplay between the atmosphere, oceans, rocks, and living organisms, helps to regulate Earth's temperature. These interconnected systems have worked in concert for billions of years, maintaining a delicate balance that has allowed life to flourish. Earth's story is one of cosmic serendipity and remarkable resilience. From a swirling cloud of gas and dust, our planet emerged, endured a tumultuous youth, and blossomed into a vibrant world teeming with life.